Okay, what? How far did we get? Okay, I'm in the wrong. I'm in the wrong spot. Are we? Are we on the homework? Okay. 26. Ah, all right. I remember. That's why we stopped yesterday. Yeah. Create a graph for each of the following functions using the given conditions. So this function has the following features. Down, down. I thought you were going to say up. All right, here's the first feature that we need of the graph. I guess you guys need graph paper, huh? What's that? Oh my God. Our world is in so much trouble. That's your response, huh? Someday you're going to get a job. I can't do that. It's too hard. Yeah. It was on the module 2 stuff. Okay. And Matt, you got one? Okay, so we've got the following features. F of 2 is positive. So what that means is if I go to x equals 2, the graph is going to be above the x-axis at that point. But it doesn't say where, so we're just going to kind of leave that off, but we just have to remember that it's going to be up here somewhere, okay? Then it says f of negative 2 equals 0. So over here I need f of negative 2 to equal 0. That means when I go to x equals negative 2, y equals 0. That means the point is on the x-axis. Okay? Then it says the function is always increasing and has a domain of all real numbers. So what do you want to do? I'm going to put a random point up here somewhere. Okay. 4. Okay. 1, 2, 3, 4. Okay. Yeah. And then if we connect those dots, whoops, I kind of missed a little bit there. There. Then we have f of 2 is positive. Check. F of negative 2 equals 0. Check. It is increasing the whole time. Check. And it goes to the left and to the right forever, ever, ever. Okay? So we have met all the criteria. Yeah. Okay? All right. Next one. This function has the following features. So let's get a little graphing going. Okay, f of 3 is greater than f of 6. So 1, 2, 3, 1, 2, or 4, 5, 6. So this means that the point that we plug in at 3 is above the point that we have at 6. I don't know if it's going to be exactly at those points. I just took Luis's advice and just chose some random ones. We might have to move those to make it fit with the rest of the stuff. All right, then it says f of 1 equals 0. What does that look like? Yep, 0 right there on the x-axis, okay? F of 2 equals 4. So 2 would go up to 4. Yep, so we might have to move those points because that is weird. And then f of x is increasing from negative 5 to 3. So do you guys see how I'm going to have to move this point up a little bit because I need it to be going up the whole time? Should I move it up like, oh really? Should I move it up 4 so it lines up with the other one? Like that? Is that nice? All right, and then the domain is just from negative 5 to 10, so that means that it's going to go, okay, now I can't get to negative 5. So I'm going to cheat here. 1, 2, 3, 4, 5. So I'm going to start there and go like that. So it's not like linear, but it's all good. And then it goes all the way to 10. So 6, 7, 8, 9, 10. I just went wherever exactly. So maybe something wacky that looks like that. So from negative 5 to 3. Right. Make sense? Okay. All right, so once again, let's make sure, is f of 3 greater than f of 6? This is bigger than that, so yes. F of 1 equals 0, yes. F of 2 equals 4, yes. It's going up from negative 5 to 3, yes. And the whole thing is only from negative 5 to 10. Okay? What's that? Once again, meets all the criteria. Yeah. All right, number 28. All right, this function has the following features. F of x has a constant rate of change. What in the world does that mean? What do you mean? Okay, good. Do you guys see what Nathan did? That's exactly right. It's going constant, it never like this, okay? So the math way of saying that is if it has a constant rate of change, that means it's a straight line. It doesn't do any weird stuff, okay? So f of 5 equals 0. 1, 2, 3, 4, 5. So that's 0 right here. So for this one, I just have to draw a straight line that goes through that point. So up or down, or what do you guys want? Up, okay. No, because it doesn't say what it is. It just says it is constant. So like Nathan said, it can't be squiggling around at all. It has to just be, and then f of 5 equals 0. So that's this point right here, 5, 0. That's it. Once again, yeah, and that only had 2, so that's pretty easy. Okay. Okay, last one. Create your own condition. I think we can just cut that one out. Okay, so this was notes, right? Okay, so you guys can just add those graphs to your notes. You don't need to staple those together and turn them in. So let's take a look at the homework. Well, this is your exciting time now, Weston. Because we're running up to the end, getting to the end of the deal here. There's a lesson 7 notes, right? But there's lesson 7 notes, right? I mean, Yeah, right. And then right, because then you get to have a test. Yeah.
You have a review for data that test, right?
Yes.
How long do we get that day?
The data test,
Yeah.
the data review. I don't either. I don't think so. All right. In prior work, the meaning of f of x equals g of x was discussed. This means to find the point where the two equations are equal and where the two graphs intersect. It's possible to find the point of intersection algebraically instead of graphing the two lines. Since f of x equals g of x, it's possible to set each equation equal to each other and then solve for x. So, for example, if you wanted to find the point of intersection of those two things, you could graph the lines and then see where they cross. But judging from Nathan's reaction to getting a piece of graph paper out, graphing is not the favorite, right? So you could do it algebraically instead. So to do that, you just write the two things being equal to each other, and then you solve them, okay? So you subtract 3x, subtract 1, and then you figure out what it is from there, okay? So let's do that. Find the point of intersection for f of x and g of x using the algebraic method in the example above. So, yep. So first step, you just write the two equations equal to each other. Okay? And then we just have to solve that for x. So how do you want to do that? Okay. Yep. So Weston says let's add 5x. We could, slow down there, big guy. We could have added 2x to both sides if we wanted to. It didn't matter, but what Weston says is exactly. So Matthew says x equals 5. Louise points out, well, that's only one number, because that's what x is. So then, right, we have to put that in to figure out what the other number is. Plug it into either one of these two functions. So negative, it's not negative 10x, it's negative 10. Because if you plug 5 into here for x, negative 2 times 5 is negative 10. And then negative 10 minus 3 is negative 13. Okay? If you'd plugged it into the other one, you'd get the same answer. If you plug 5 into there, negative 5 times 5 is negative 25. Plus 12 is also negative 13. They'll work out the same for both of them. That's an option too. Yeah. Hadn't thought of that. Nice job. Way to think outside the box. Okay, blank page. All right, next one, same thing. 1/2 x plus 2 equals 2x minus 7. Okay, if I subtract a half an x, nice. Okay, slow down. Okay, I'm not a smart dude, just calm down. So the first thing Matthew said is the same thing that Weston did with the other one. We're going to get the x result. So 2x minus half of an x is 1.5 x's, right? So now we've decided to get all the x's on the right, so we need to get all the numbers on the left. So we're going to add 7 to both sides. So 2 plus 7 is 9. So if 9 equals 1.5x, then x must equal 6. Okay? So then to figure out what y is, right? Pretty nifty, huh? Kind of, yeah. All right. Okay. I don't know what to say. Um, all right. So number 3 is the same thing, but the numbers are a little bit trickier. Which one do you want to add to where? You want to go plus x to that side? Okay, I like that. What is negative 2/3 of an x plus an x? If you say negative to start with, you're wrong. Yeah. Nope. 1/3 x. Yeah, it's basically negative 2/3 x plus x is the same as x minus 2/3 x. So if you're taking 2/3 away from 1, then you have 1/3 left. Okay, yeah. Okay, what now? Minus the 5. Positive 6. You're close, but there's no negative. So, yeah. Yeah, you just dropped the... I remember reading something like the if you add up the money that someone makes who's graduated from high school versus someone who has not graduated from high school over their lifetime, on average, the high school graduate will make $100,000 more. So you could argue that you're getting paid $25,000 a year to go to high school. Yeah. Right. No. Then you get it paid to you very slowly over the course of the rest of your life. Okay. All right, number 4, same dealio. You think so, do ya? They don't cancel. Right. So, right. No, you're right. X equals 0. It's not because the x's cancel, it's because the 6's cancel. So if, no, one's negative and one's positive, so they don't cancel. So x plus x is 2x minus 6 equals negative 6. But when you add 6 now to both sides, then you're right. Yeah, so 2x equals 0, which means x has to equal 0. Good. And then y is negative 6. You guys got this. Yes, you're smart. Congratulations. It finally happened. Ding! Okay. So let's stop this for a second.